All right, in this video we will continue practicing how to graph sine and cosine functions with reflections over the x-axis and changes of amplitude, reflections over the y-axis, changes in period, and now phase shifts, which are horizontal translations. Let's use the sine function as an example. If I have a function in the form y is equal to a times the sine of b, and then in here I'm going to have x minus h, and then plus k. All right, this is a sine function with everything on it. Let's talk about what each of these things does. This a controls the amplitude. All right, the amplitude is going to be the absolute value of a. Amplitude is always positive. This b value controls the period. All right, the b value is not the period, but the period is always going to be 2 pi divided by that b value. So that's going to give you the period. The k value, let me skip over here. The k value is going to be a vertical shift, or a vertical translation. All right, so if this is a positive number, we're going to shift up. If this is a negative number, we're going to move down. And finally, this h value is going to be a horizontal shift. Now, when we are dealing with periodic functions, these functions that repeat over and over again forever, a horizontal shift has a more specific name called a phase shift. All right, so a horizontal shift is called a phase shift when you're dealing with a periodic function. And you'll find it right here, being added or subtracted. Okay, now, that should be enough background information to get us started. So for number 15, I see the a value right here. Because of that a value of -3, I know that the amplitude will be +3. All right, amplitude is always positive. Now that negative sign is going to be a reflection over the x-axis. So this function will be upside down, but we'll deal with that later. Now the period, the b value goes right here. Because there is no visible b value, the b value is 1. So the period is just going to be good old 2 pi. Now the phase shift, that happens when you have something added or subtracted from the x right here on the inside of the function. There is nothing added or subtracted from the x. So there is no phase shift for this particular problem, so I'm just going to go ahead and say none still. So this should be enough information for us to sketch this graph. Okay, so here's my x-axis. Because the amplitude is 3, I'm going to go up to +3, and I'm going to go down to -3. Because the period is 2 pi, I'm going to come all the way over here and I'm going to put 2 pi. Then halfway in the middle should be pi. Half of that should be pi over 2. And this should be 3 pi over 2. Now, this is a cosine function. And we have learned that a cosine function normally starts off up high. Like, let's see, how do I want to do this? The cosine function normally starts off high, and then it goes low, and then it goes high again. All right, so if there were no negative sign here, this would be what my cosine function would look like. But because of this negative sign, it's a reflection over the x-axis. So this has to be upside down. So that's why I'm going to go ahead and draw my cosine function upside down like this. And that is what number 15 should look like. Take a look at number 16. The a value goes right here. There's no number there, so it must be a 1. That means the amplitude is 1. Now the b value is this number right here. Now that is going to affect the period indirectly. The period is always 2 pi divided by the b value. Now it's really going to be the absolute value of the b value. I'm not going to put -3, I'll just put 3. And that's it. This doesn't reduce or anything. So 2 pi over 3 is the period. All right, notice it is positive. Phase shift. Phase shift happens when you have something added or subtracted from the x inside the function. There is nothing added or subtracted in here, so there is no phase shift. By contrast, when we get to number 17, this is what a phase shift looks like. Okay, but for now, we're just going to say none. And this should be enough information for us to graph this function. Okay, let's go ahead and get started. Oh, okay. You know what? I better mention one more thing right now. This negative sign on the inside, like this, is a reflection over the y-axis. All right, reflection over the y-axis. Okay, that is the significance of this. That is a reflection of the y-axis. Because of that, I need to leave space on both sides of the y-axis. So normally when I do these graphs, I put the y-axis over here on the left side. But this time I'm going to put the graph right here in the middle, so I have space to do a reflection over the y-axis. The amplitude is 1. So I'm just going to come up here to +1, and I'm going to come down here to -1. The period is 2 pi over 3. So I'm going to come way over here, and I'm going to put 2 pi over 3. Now if I go halfway, if this is 2 pi over 3, then halfway should be 1 pi over 3. So I'll just put pi over 3. Now if I go half of that, half of pi over 3 is pi over 6. Okay, now this third position should be 3 of these. So this position here should be 3 pi over 6. But take a look, 3 goes into 6 twice. So this reduces down to pi over 2. So that's why I'm going to put pi over 2 right there. Now on the left side, it's just going to be the negative of each one of these. So this is negative pi over 6. And this is negative pi over 3. And this is negative pi over 2. And this is negative 2 pi over 3. So let's go ahead and do the graph. First I'm going to graph it without the reflection. So if there was no negative sign right here, let's see, this is a cosine function. So I would know to start off up high like this. And then I would go down to the midline, and then I would go low. And then I'd go back to the midline, and then I would go high. So this would be how the graph would look if there were no negative sign. Now, because there is a negative sign, I need to take these 5 critical points and reflect them over the y-axis. So this point that's on the y-axis isn't going to move. But the mirror image of this point is here. The mirror image of this point is going to be at negative pi over 2. The mirror image of this point is going to be down here. And the mirror image of this point is going to be over here. So hopefully you can see that this set of blue points is the mirror image of the red points. It's the reflection over the y-axis. So these are the values that I will graph. So that's what number 16 should look like. I am excited to graph number 17 because this is my first graph that has an actual phase shift. Now the A value goes right here. There's nothing visible, so the amplitude must be 1. Now the period is affected by the B value. Okay, the B value goes right here. The fact that there's no number sitting there tells me that the period must remain 2 pi as normal. Now what we do have right here is the phase shift. The phase shift is a horizontal translation. It's going to be the opposite of what you would normally think. So a phase shift, because I see minus pi over 2, the phase shift is actually going to be to the right pi over 2. All right, so it's going to be pi over 2 to the right, plus pi over 2. All right, so it's always the opposite of what you see here. So what I'm going to do is I'm going to start off by ignoring the phase shift. So let's see what this would look like if there was no phase shift. Okay, so normally I would just do this. Okay, my amplitude is 1, so this I have 1 and I have negative 1. The period is 2 pi, so I'm going to put 2 pi over here like this. Okay, in the middle here this is pi, and this would be pi over 2. And this would be 3 pi over 2. Now, if there was no phase shift, I would just plot my sine function the way we have memorized. It starts at 0, and then it would go high, and then back to the midline, and then down low, and back to the midline. That's what it would look like. But because the phase shift is to the right pi over 2, each of these dots should move over pi over 2 to the right. So always begin with the dot that would be at the on the y-axis. This is going to move over pi over 2 units. So if I take this and move it over pi over 2, then it's going to land here. All right? So I'm hoping you can see that I've taken this dot and I've just moved it over to the right by pi over 2. All of the rest of these dots will follow that same exact pattern. So see how these are all sort of one mark over? So every single dot is just going to shift over by pi over 2. They're going to all shift over one mark. So this is going to move here. This dot is going to be here. This dot is going to be here. And this dot will be here. I need to add on another mark. Okay. And I need to label this very clearly. So this is like 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. This would be 5 pi over 2. And it must be labeled for full credit. So I'm going to put this dot here. So this is what the actual graph should look like. All right, notice that it has been shifted to the right by pi over 2 from the pink dots. Take a look at number 18. The A value goes right here. There's no number there, so the amplitude must be 1. The B value goes right here. There is no number there, so the B value must be 1, which means the period must still be 2 pi. But what we do have is a phase shift. All right, that's what you get when you have something added or subtracting inside the function right next to the x. It's the opposite of what it looks like, though. So this plus pi over 6 is actually pi over 6 to the left, not the right. So the phase shift is going to be pi over 6 to the left. Okay, so let's go ahead and do the graph based on this information. So here's my x-axis. And there's my y-axis. The amplitude is 1, so I'm going to have my positive 1 and my negative 1 like I often do. The period is 2 pi. So I'm going to start off by putting my 2 pi over here. 2 pi. And then right in the middle would be pi, and right here would be pi over 2. And this would be 3 pi over 2. If there was no phase shift, I would just graph my standard sine function, which would start from the origin, and then it would go high, back to the midline, and then low, and then back to the midline. But I need to shift each one of these points to the left by pi over 6. Okay, that's just going to be a little bit to the left. So here's what I want to do. I'm just going to put a little mark a little bit to the left of each one of these positions. All right, pi over 6 is a very small amount, so it's just going to be a little bit to the left of each one of these. But the key is we have to name them. I can't just put a mark. I have to name them. So how am I going to do that? Well, the first one is easy. I went left pi over 6 from 0. So of course this is negative pi over 6. I think I'm going to need a smaller pen. So this is going to be minus pi over 6. Now what about this one? Well, this is pi over 2 minus pi over 6. Okay, that's how I'm going to find the name of this. I'm subtracting pi over 6 from everything. So I need like denominators though, so I'm going to multiply this by 3. So this is really 3 pi over 6 minus 1 pi over 6, which is 2 pi over 6, which reduces down to pi over 3, all right, because 2 goes into 6 3 times. So this little mark right here is pi over 3. Okay, let's do that again. I need the name of this little mark right here. Well, it's going to be pi minus pi over 6. Well, pi is the same thing as 6 pi over 6. So it's 6 pi over 6 minus 1 pi over 6. So that'll be 5 pi over 6. So this mark will be called 5 pi over 6. What about this mark right here? Well, it's to the left of 3 pi over 2. So I'm doing 3 pi over 2 minus pi over 6. All right, because that's my phase shift. Well, I need like denominators. So I'm going to multiply this by 3. So this is really 9 pi over 6 minus 1 pi over 6, which is 8 pi over 6, which reduces down to 4 pi over 3. So that's going to be the name of this, is going to be 4 pi over 3. Okay? And last one. This is 2 pi. All right, so I have 2 pi minus pi over 6. Okay, so 2 pi is the same thing. If I multiply these by 6, that's going to be the same thing as 12 pi over 6. So I've got 12 pi over 6 minus 1 pi over 6. So that is 11 pi over 6. All right, I know it's getting a little bit crowded in there, but what are you going to do? All right, so those are the names of all those points. So now I can go ahead and do the shifting, and if I move each of these points over, they will land just a little bit to the left of where they are. And there you go. All right, let's look at number 19. All right, the A value goes right here. There's nothing there, so the amplitude is 1. The B value goes right here. All right, there's nothing there, so the B value must be 1, which means the period must be 2 pi. Now, we do have a phase shift right here. This pi over 2 tells me that there will be a phase shift. This phase shift will be to the left by pi over 2. So this is going to be pi over 2 to the left. It's always the opposite of what it looks like. Okay, so let's go ahead and do the graph. Hold on, I got a little crooked there at the end. Let me try that one more time. Okay. So the amplitude is 1, so I'm still going to do my positive 1 and my negative 1. The period is 2 pi, so I'm going to come over here and I'm going to put my 2 pi like this. Halfway across, I should have pi. Half of that is pi over 2. And in between these two should be 3 pi over 2. Now, if there was no phase shift, the cosine function would look like this. It would start off at 1, and it would go down to the midline, and then it would go low, and back to the midline, and it would go back up to 1 again. Now, with the phase shift, I have to move each one of these points to the left by pi over 2. Now that's going to be pretty easy because these units are each pi over 2 in width, you can tell from the first one. So if I go to the left by pi over 2, then this is just going to be negative pi over 2. So if I take this point and move it to the left pi over 2, this first point is going to end up here. So I hope you understand that what I'm doing is I'm taking this point and I'm moving it to the left by pi over 2. Now if I move each of these that same amount, okay, so this first one landed here, this one is going to land here, this one is going to land here, this one is going to land here, and this one is going to land here. So this is what my cosine function is going to look like now. Okay, so it's just the regular cosine function, but shifted to the left by pi over 2. All right, This video is getting quite long, so number 20 is going to be the last one in this video. So let's see, we have an A value of 4. That tells us that the amplitude is going to be 4. The amplitude is always positive. Even if this were a -4, the amplitude would still be positive 4. The B value goes right here. There is no visible B value, which means that the B value is 1, so the period is going to remain 2 pi like normal. Now, we do have a phase shift right here. It's the opposite of what it looks like. So this will be a phase shift of pi over 4, but minus pi over 4 is actually a phase shift to the right by pi over 4. Okay, so let's go ahead and do the graph. Okay. So the amplitude is 4, so I'm going to make sure that I'm going to go up to 4 and down to -4 when I do this graph. Now I'm going to leave a little extra space at the end of my graph so I can shift to the right by pi over 4. So I'm going to go ahead and put my 2 pi right here for the end of my period. So if this is 2 pi, then of course right in the middle I should have pi. Half of that should be pi over 2. And in between here, I should have 3 pi over 2. Now, if there were no phase shift, then this is what the graph would look like. This is a cosine function, so it would start off up high, and then it would go to the midline, and then it would go low, back to the midline, and it would end up high again. So these 5 critical values would show me exactly where the function would be if there were no phase shift. But I need to move each of these points pi over 4 to the right. Now, half of pi over 2 is pi over 4. So if I were to put a mark right here, hopefully you can understand that this would be pi over 4 right here. So pi over 4 is half of these marks. So as I'm moving to the right by pi over 4, in this particular case it's going to be exactly half of the distance each time. Okay, so I had pi over 2, and then 2 pi over 2, 3 pi over 2, 4 pi over 2. I'm going to put a 5 pi over 2 over here. And then I'm going to wonder, all right, I need to find the names of each one of these marks. Now, because they're exactly in the middle, I can find these green names by counting. This is 1 pi over 4. This is 2 pi over 4. It reduces. This will be 3 pi over 4. This is 4 pi over 4, which reduces. This is 5 pi over 4. This is 6 pi over 4, which reduces. This is 7 pi over 4. This is 8 pi over 4, which reduces to this. And this would be 9 pi over 4. So it's important that you have accurate names for the places where your dots will land, where your critical points will land after the shift. Okay, so great. If I move this pi over 4 to the right, it's going to land right here, directly above. If I move this one to the right, it will land here. If I move this one, it'll be here. This one will land right here, and this one will be directly above the 9 pi over 4. So there you go. All right, and that is what the graph of number 20 should look like.